All right, in this video, we're going to go ahead and we're going to take a look at two things that we've been working on. Is that we're going to be examining the graph, okay? And we're going to go ahead and be examining a table that goes along with the graph. And then we're going to be answering some questions about that particular graph, okay? And making our own equation for it. So let's go ahead and start with some of the information that we need to go ahead and um, have down first. So it's a real world scenario. That means it happened in the real world. And it's the middle of winter, so there's some snow. This is not Sacramento type problem, but it does happen in other parts of the world. It says there is originally blank inches of snow on the ground. We don't know that when a blizzard begins. The snow falls at a constant rate. That means is that it falls in a linear rate. So our graph is going to look like a line. The rate at which the snow falls is blank inches, okay, per hour. And so we have this graph right here, okay, and we take a look at the time passed in hours, okay, that's going to be our x coordinate, and our y coordinate is going to be the amount of snow that has accumulated on the ground in inches. So let's go ahead and I like to get, address these types of problems last after we get all of our mathematical or our numeric information on it. Okay, so let's go after this table of values. Okay, so if we look at this table, this says that x, okay, right here, oops, that's a highlighter, that x, when it's 0, y is going to be some particular number. So if I look right here, I notice that when x is 0, okay, which is right here, then that means is that y is going to be, I look at this and I say, all right, that's going to be 1, 2, 3. And so I know that my output is going to be 3. Okay, so let's go ahead and take a look at the second one, which is going to be 2. All right. So we go to where x equals 2. And remember that x, this is hours that have passed, okay? And so if I go to 2 and I make another point where that hits on the graph, we notice that it is going to be 1, 2, 3, 4. So we have our point, which is going to be our y value, which will be 4. Okay? And we have the next one, which is going to be a 4. So let's find the 4 on the x-axis and draw counting on up to where 1, 2, 3, 4, 5, where it hits the actual pre-graph line. This is our next point. So we end up with an output of 5. Finishing things up, we got 2 more rows to go. So we're going to find a 6. And then we're going to count up 1, 2, 3, 4, 5, 6, and we're going to make that point. Okay. And lastly, we can probably start making some predictions. And I think some of us that are looking at this be like, well, I pretty much know what's going to happen here. Okay. Is that it looks like this predictably is going to be a 7 because they're going up by 1 each time. But let's go ahead and just confirm graphically about our assumption. So I'm going on over to 8 right here. And I'm going to follow it up and make the point. And so at 8, I have a 7, like we predicted. Okay, so now that the table is all set, we can go after the equation. And so let's go ahead and review, like we did in class, how to go ahead and set up an equation. So we look at it always has a y, okay, and it has a slope or an m, x plus the y-intercept b, okay? So remember that m, it stands for the slope, which is also going to go ahead and stand for, we're going to find out, the rate. And the y-intercept or the B stands for the y-intercept. And it's also going to go ahead and be a starting value or initial value. So that in mind, let's go ahead and build this thing based on our graph. So the parts that are written in black always stay the same, okay? And so we have x, and I'm going to leave a blank there, plus, and then leave a blank there. So we need to go ahead and find out how do I find that m or the slope. So as we practiced before, let's go ahead and zoom in on these points right here and see how we might find the slope. So I'm going to use this point here and this point here. So what we're going to do is that for the slope, we know that what is the logical connection between the next point on your graph. And so what we do is that we set it up where it's just like how much we go up or down, okay? So how much we go up or down and how much we go to the right, okay? If it's positive, we know we go up. If it's negative, we know we go down. And so I go up 1. So that means is that since I go up 1, that's going to be a positive 1. And I go to the right 2 to get to the next point. And so therefore, I put on the bottom 2. So my slope is going to be 1/2. So let's put that in our equation. Next, an easier value to find most times is going to go ahead and be the y-intercept. And that is just where that hits, the line hits on the y-axis. So we know that this point is 0, 3, when x is 0, okay, y is 3. So 3 is going to be our y-intercept. So moving back to our work area, we have this business of 3. So that's how we build our equations or any equation that we need, and the table. So our last order of business is to start looking at all of these real world scenarios and answering the questions. So let's take a look. It says, is the middle of winter. There is originally blank inches of snow on the ground when the blizzard begins. So that means is that when something is just beginning, the time that has passed, time passed, is going to be 0, 0. And the output is for when that is 0 is, in this case, is going to be 3. So I have a 3 here and a 3 here. So it makes sense that there would be, after 0 minutes have passed, there are 3 inches of snow on the ground. So the snow falls at a constant rate. That means, as I mentioned before, like a line. Okay. The rate at which the snow falls is blank inches per hour. Well, that is our rate that we found out, which is the slope. Okay. So what we can do is that we can take the slope that we've already done, and the rate at which the snow falls per hour is going to go ahead and be 1/2 inches per hour. Okay. Or a 1/2 an inch per hour. So that said, let's go ahead and also take a look at checking for understanding here. Okay, is that we're going to go ahead and say, all right, well, how much, okay, snow was on the ground when the blizzard started, okay? So that means is that it seems like we already curated that. So that means is that there were 3 inches. And we want to make sure that we're always putting our units on there. And then after 11 hours, okay, so they're extending on the table. After 11 hours, how many inches we're going to go ahead. And I'm pointing to the 8, but at the same point, that if we extended this table, how many inches would be on the ground? Well, there's 2 different ways that we could do that. So let's start with just finding, let's see, 11 on the x-axis, and we move it all the way up, and so it looks like it's going to hit right here. So from the graph, we can say that after 11 hours, there's going to be 1, 2, 3, 4, 5, 6, 7, 8.5 inches on the ground. And so our correct answer would be 8.5 inches. Okay. One additional way that we could do this is going to go ahead and be using the formula that we made and plugging in, pardon me, and plugging in the 11 to it. So if I start off with the formula y equals 1 half, and we built this up top, x equals, or at plus 3, and I drop in the 11 from the problem, okay? So that means is that after 11 hours, how much y amount of snow on the ground, okay? In inches. So we cut 11 in half, and that's going to give us 5.5 plus 3, and 5.5 plus 3 is going to give us 8.5, which is going to be the same as 8.5 inches. It's just a different way to go ahead and write it in decimals. So your assignment is in Google Classroom, and there are two problems there. One is an identical one to this one, and then there's another one that has a little bit of a different feel to it. So I want you to head on over to the Google Classroom and try what lies in wait for you.